Okay, people, you asked for it. So I'm going to start going through computer science past papers. I'm going to have to do this in multiple chunks though, and then I'll put them together so that you've got a complete video. But at least you'll have like a part one coming out each week and then a part two. They do take about 2.5 hours to do, so it's I've only got so many hours in the day. But you asked for it, so this is why I'm doing it. If you don't know me, my name's Josh. I was a computer science examiner and I was a head of computer science. I now run a tutoring business. And the thing that I want to teach you about in all of this is obviously I want to teach you how to get good marks on exam papers, but I think the main message that I want to do is it's all about the importance of keywords. There's certain buzzwords which you need to be saying to get marks. The amount of times when I see people drop marks, maybe they only get 1 out of 2 or they don't get any marks. And this is little things which you will start to pick up in the way that I'm talking about where marks are given throughout this. So that's the thing. If you're going to be making flashcards going on throughout, make sure that you write the exact wording of this if I start talking about a particular buzzword or a certain keyword to get the marks. So let's have a look at this. Let's get going into it. So first one that we've got here is describe the von Neumann architecture. So with the von Neumann architecture, the way that they're going to be talking about this question is it's all to do with how the CPU is set up. Okay, they've given us a little bit of information up at the top here, talking about how it's got 2.4 gigahertz, 2 megabytes of RAM, and there's given us some information there. So with the von Neumann, it's the idea that it's got data and instructions are stored in the same memory location. It also has a singular bus which is used to transport the data and instructions from RAM to the CPU. So buzzwords that we're talking about there is data and instructions are stored in the same memory location. This is because it's a comparison point to Harvard architecture. Harvard architecture is where it has separate data and instruction locations, and they have separate buses, which is to do with increasing speed. So as you can see here, give one way that Harvard architecture differs from von Neumann, the follow-on question there, and that's quite a common thing, a common pattern that you'll see in exam papers, is it has separate memory stores for instructions and data. Okay, the charity is concerned about the performance of the computer is not sufficient and wishes to replace the processor. Give 2 features of a replacement processor that would increase the typical performance. So this is all to do with the idea of like what are the different factors that you can do to increase the performance, or just affect the performance of the CPU. So what I would go for is obviously you've got clock speed. It's a 2-mark question, so it's not asking. It says give 2 features here, so it's just going to be clock speed. You could also say cache size, multiple cores. More of an A-level one is about word size as well. Is that if the word size is larger, then that can affect the performance slightly better. Okay. Now, so we're going on to the first assembly code, little man computer question. Okay. Now, a couple of little tips on this one here is I have got another video about assembly language. So if you have no idea about assembly language, make sure it's specific to your exam board as well, because AQA, Cambridge International, would actually do a very different one. So I know that you can watch other exam papers and you can get some information from them, but this isn't specific to AQA or Cambridge International. So this is all for OCR. Now, the way that I would probably go about doing this is it's about understanding what is in the accumulator at particular moments. You could even go onto the little man computer. So if you go on Google and you type in little man computer and you go onto here, you could potentially trace it through on here, and that would be a really good activity. It's overwhelming, I'm not going to lie to you, in terms of like the first stages when you're starting to learn about the little man computer. It's very difficult to actually understand what's in the accumulator, and that only comes through experience. So that would kind of be my main suggestion about trying to do it. And Sorry, shameless plug, but we do have a little computer science group, A-level computer science group, where we go through these things. I'll put a little link in the description, but so anyway, what we've got on this one here then, so it says, essentially it's working out how much money is going to get donated to charity. So I'll try and trace it through so that you can see what's going on. So the program shown in figure 1 is run once using 3 different inputs. Therefore, while the program is running once, it will output the updated total 3 times. So it's going to go through, we're going to input 3 values whilst this is running. Then what we're going to do is we're going to put in, so for the first thing, we're going to store in donation 10. So if we just write a 10 just to remember what's going on, we're going to subtract 100 away from that, which obviously that gives us minus 90. Now the instruction here is going to be BRP bonus. So that says branch if positive. So if this number, because this number here is now in the accumulator, the branch decisions look at the accumulator, this thing, and thinks should they branch based on what's in there? And in this particular circumstance, it isn't, because it's negative, isn't it? We're then actually going to load total, which if you have a look at total, that's 0. So there's nothing in there at the moment. We add the donation to it. So now in total, there's going to be 10. And we store that in there as well. That's a really common thing, which people don't understand, is we have to overwrite it quite often. So it's like with with assembly language, you have to overwrite things all the time to make sure that the data updates. And that's quite a common thing. And then we can and then we go to output, and it says output for 10. So we just got 10 there. And then we've got BRA, branch always, which just means it's going to do this wherever it's always going to do this. So it's going to just jump back up to the start. And then we're going to input in 50. Okay. So we input in 50. If I take this off, just so that we can kind of keep track of what's going on and it's not taking up too much space then. So then we're going to put in there 50. I'd be writing this information down because it's too much information for you to kind of keep there. Keep that 10 there for me as well. So then we're going to put that in 50. We're going to sub 100, which obviously gives us minus 50. We're going to do a little check. Is it positive? Are we going to get a bonus? No. And then we're going to load total, which is 10. We're going to add the donation. So this goes from 10 to 60 now. So a little mistake that I would see a lot of people making on this one is they would think that's 50. Because it just continues running all the way through. So that's going to go 10 to 60. Then we get to the last one. Just take these off. Okay, and then final one. So then we're going to jump back up to the top. BRA back to the start. And then we've got 120. Store that in donation, which is going to be, so we've got that in 120. We're going to subtract 100, which is actually going to be 20. So BRP is what's in the accumulator positive. It is. So we're actually going to jump ahead. And we're going to go on to, and then we can see here it goes load total, which is 60. Add the donation, which is 180, because 120 plus 60 is 180. Add a further 20, which is 200. Store that in total, and then that's going to be, and then we're going to output that. So the final value is actually going to be 200. Okay, and then we're not inputting any more values in there. So then it does jump back to the start, but there's nothing left to do because those are the only 3 values we're going to input in there. Okay. So onto this now. So the next page. So write an LMC code that will reset the value of a memory location labeled total to 0 and then stop the program. So we will have a memory locate. We'll probably have a label which will be associated with 0. So we'll do LDA. Can put it in all caps. Sometimes that makes things a little bit easier as well. I don't think they would be too picky on it, but it's better not to take any chances. So I think probably put it in all caps. I know that you're handwriting it and I'm typing it, but anyway. Then what we're going to do is we're going to go for store. So LDA 0 will load that into the accumulator. So 0 will get loaded in there because I'll show you how to pre-select for 0 in there. And then what we need to do is we're just going to store that in total. So it's going to reset total essentially. And then what we're going to do is stop the program. Now this is the important part, okay? at the end here, what I've got to do is I need to hard code 0 into the label 0. So remember, at the end of all assembly language programs, what we've got to do is we do 0, dat, so you put the label, then dat, and then you're going to put the number 0 there to hard code that in there. So essentially what goes on there, you load 0, which is 0, you store that, you overwrite whatever's in total with 0, you stop the program, and then you just hard code your value in there, because you always declare your variables at the end because of how the von Neumann architecture works. Okay. Next one. It's running on pipelining. Define the term pipelining. So again, there's going to be some buzzwords here, people, which again, people will miss this. So it's the concept that they want you to get, and also it's 3 marks this as well. You would have thought it'd probably be a 2 marker, but 3 marks. You've got to be thinking, make 3 solid points. So this is where it's going to be that essentially the concept that they want you to get is that as one core is fetching, the other core is decoding, and the other core is executing. So as one core is fetching, the other core is decoding, and the other is executing. That's the idea of pipelining, and it's something which happens in RISC processors. So with that, I would have probably have said like that's enough for 3 marks, but I seem to remember on this mark scheme that actually that wasn't enough. So sometimes maybe just go a little bit over the top. It's like clearly you know what you're talking about there, and maybe make another point just to really hammer it home. So I would be saying this allows for parallel processing, which is that. So that will get you the final mark, but that's surprisingly difficult to get the 3 marks, because I think a lot of people would have thought actually the top one there. So just go a little bit over what you think is actually going to be necessary. Okay, last little part here then is explain one benefit of the charity of using a processor that allows pipelining. So I'd just be saying it's going to increase the number of instructions done per second. So that just means that your computer is going to be better, or better is a little bit vague. So can you see that I'm always like course correcting? You want to use terms. Remember I was saying about buzzwords. So I would be saying the more instructions done per second, which would get you 1 mark, the computer will then run more efficiently. That's a bit more of a statement, sounds better, what the examiner is specifically going to be looking for in there. What you don't want is you don't want the examiner having to think, should I give you the mark for this one? So that's why it's really important to study the mark scheme, study the keywords that they're kind of looking for, so that you get into a style of writing. And this is something that isn't really talked about that much. That exam technique is a skill, okay? Being able to write in a way that the examiner is more likely to give you marks is something that's super important. You got to think that an examiner is ultimately a human being, and even if when eventually AI is probably going to start taking, particular marks and, is going to be marking quite a lot. There's going to be a style which that AI is trained on, and there's a style that examiners, I was one for a number of years, that are trained to mark on, and that person could be a little bit tired, they could be all of these different things. So you've got to make it as easy as possible for it, which is why you've got to study these mark schemes and be like, what is the style they want me to write in? And I just don't think there's enough, it's not enough. We don't spend enough time as teachers talking about this. You got to write in the way that they're expecting, because you don't want them guessing whether you get a mark. So anyway, explain one benefit of the charity of using a processor that allows pipelining. So more instructions are completed per second, which means they are more likely to. No, it's not more likely that the computer will run more efficiently. Okay, so 2 solid points there. So top one, more instructions completed per second, and the benefit of that is, that it's going to work more efficiently. Just got to click off there. Right, let's go on to the next ones. Processor contains registers. Okay. The contents of these registers are modified using the fetch, decode, execute cycle. Describe how the accumulator is used. Okay, so this is one where big transition from GCSE, where you could make 1 point, one kind of generic point. Accumulator holds stuff that the ALU does. So let's make that point. Let's still use our GCSE knowledge. Stores content, stores results from the ALU. Okay, that's going to get us a mark, but we've got to make 2 points, and that's where this is a hard part. This is the A-level thing that I would add. Branching decisions are made from here. Okay, so describe how the program counter is used during the fetch, decode, execute cycle. Okay, so in this one here again, so we're going to make the point is hold the address of the next instruction, remembering those keywords from GCSE. If you did AQA, you might not be familiar with that, and then you've switched over to an OCR course, because I don't think you do registers on that. But anyway, holds the address of the next instruction. And also the other thing that I would say is, because it says about describe how the program counter is used during the fetch, decode, execute cycle, you can say that it's incremented, which just means it goes up by 1. Incremented once the data is passed from the PC to MAR. Okay, you might also make a note about how it this was actually a thing which I remember examining one year, and it was talking about how there couldn't be any inference that the program or any of the registers did any of the parsing, because all they do is store the data, which I thought was really, really harsh, because it was I couldn't award the mark. And you're probably going to think to yourself that this doesn't make any sense, is that I couldn't award the mark one year where it was, if I said the program counter passes the address to the memory address register, because there's an inference there that the program counter has done the parsing and it's actually the CPU which does it. I wouldn't be able to award the marks, which I thought was super harsh, but I don't make the rules. Okay, so state name of 3 other registers. So you're just going to go MAR. MDR, CIR. Those are all of the ones that we've got to know. Okay, I don't think there's any others that you need to be familiar with. Cambridge International, there's like status register and all that kind of stuff, but I think those are the only ones that you're going to be going with. Okay, our first kind of big, long question, which I'm going to sort of talk you through a strategy of how to get some marks on this. So with all of this, essentially with the longer style questions, what you got to do is you've got to think to yourself, the structure is state what you know just about the topic. Okay, so state what you know about the topic and just any information. So there's going to be marks for, which is essentially called AO1. You don't need to know that, but it's just describing what the problem is, or about the topic that it's asking about. So do you actually understand what it's talking about? And you can get up to, especially if it's a 12 marker, you can get up to 3, maybe even sneak a little 4 marks on this one just by saying information about this. Application and evaluation, I actually think, is where it gets a little bit muddled, because it's like when you kind of apply it, you kind of end up evaluating at the same time. But essentially what they're looking for is describe, apply, evaluate. Okay, and what it's asking for us here is going to be looking for CISC, and the difference is essentially between CISC and RISC is the charity is thinking about purchasing some new hardware, some mobile devices, and they don't know whether to keep CISC because that's what they're currently familiar with, and then they're going to be thinking about also the whether they should switch over to RISC. So let's go with that and talk about what, just generically, don't even relate it to the question yet. It's just, do we actually understand what RISC and CISC is? So we're just going to write some points down. So CISC architecture, or CISC processors is probably easier. I can never spell architecture. Processors are used as a complex for complex instruction sets, meaning they have a lot more instructions that can be used within the processor. This means that it is easier for people to use as there are more instructions to access but the processor will have to do more processing of the instructions than if it was RISC. And then what I would do is then I'd follow on to talk about risks, and then I'd say RISC is reduced instruction set computers, and this is where there are not many instructions that the computer uses. This is good for translation between the instructions, between the instructions and machine code, because for every one RISC instruction there will be one machine code instruction, so it doesn't have to take as long processing the instruction. Okay, so we've wrote some information about that. Now I'm going to make another little paragraph, and I'm going to start applying it to the bit of into the different situations. So write down information and just think that you're going to have quite a bit of adrenaline in you in your exams. So what we want to do is we want to start waking. Not some of you are going to be fine, but what we want to do is we want to start getting your brain thinking about this particular topic, because essentially, we're still quite at the start of the paper. And the thing is that you can always come back to this question, as you might remember more things later on that you want to start adding in there. But giving you this structure, you start describing it, and then you can start thinking about, okay, let's start making some application and evaluative points that we could actually make on this one. So this is a little bit more generic, where it's going to be saying that CISC processors are what the team are familiar with. So it may make more sense to stick with CISC processors. Okay, so, and then I need to give a reason. Okay, so the reason for this is people will have to be trained on the newer system if they change to RISC, and this will cost money to train them. They will also lose money in productivity whilst people get used to using the new system. So there's that. Now, what we've got to do as well, because it says discuss, so that what they're trying to see is do you understand a conflicting argument either side of them in there? So then we need to say, however, flowing argument in there. RISC processors do allow for pipelining, and this will improve processing speeds dramatically. And if that is an issue, this would be a good investment, as this would improve the speeds pipelining. Also, due to the just going to move this up. Also, due to the pipelining, due to the ease at which the processor processes instructions, it does not use as much battery, which will be better for better for mobile phones, so they don't run out of charge as much. Generally, I think quite a good thing for sort of 12 marks, okay, is if you can, really go through that. And as you can see in the second paragraph, I'm kind of using a combination of application and evaluation in there so that they clearly can see that I'm using evaluative points to apply it to the scenario. So that's the way, a nice easy structure for you to go for is talk about each point that is talking about there, then apply it to the scenario and think about which would be best for there. Obviously, in lots of situations, there's no right or wrong answer. So it's just as long as you can make a case for it, go with that. And then, maybe put a little conclusive point. So in conclusion, I would suggest the short-term loss of earnings would be more beneficial in the long term to upgrade to RISC processors for the reasons outlined before. Now, you've got to trade off. This is, again, another really big thing, is like go for that. So maybe make a couple of points there and say if you've still got more points that you want to make on this particular topic, it might be best just to move on and go from there, because if you think about it, like you could maybe gain like 1 or 2 extra marks potentially. Like this may get the full 12 marks, but if not, it might actually be better for you to think to yourself, okay, I've done that. I can always come back and add more detail later if I finish early. So don't the amount of time that I would go on there is if you're averaging, I don't know, you say that you want per mark, probably give yourself 10 minutes maximum on this, okay? Because what I don't want to happen is you go way too long on this, you waste loads of time and then you don't finish the paper. So go through it on 10 minutes. You can always come back to it later on, okay? So again, exam technique. Okay, so now we're on to the database questions, where what we're going to do is state what is meant by a primary key. So just a simple definition here, a unique identifier, buzzword here, that identifies a record. Identify the foreign key used in the database and the table name where there is a foreign key. So let's have a little look. So we've got memberships. So package type is it seems to be the primary key for that one there, and it's being used as a foreign key over there. So what we're going to do is we're going to say package type. I'm also not going to take any chances. Do capitals, because can you see it's got capitals for each word. So just it's good habits to get into. Whilst they might not dock you a mark, it gets you into a good habit for a question where they might dock you a mark for it. So foreign key. So no, it's that, and then the table name, which is membership. So the reason they've done that is because they don't want you to just write package type and then membership. Struggle to spell that. Membership. There we go. Oh right, there's a little table name underneath that. Membership. There we go. The reason that they've done that is because obviously if you just put package type, you could be referring to that one, but it's the foreign key over there. So it's a foreign key is a primary key in another table. Identify the data type of the cost per month field. So let's have a little look. Cost per month. Now remember that database data types are slightly different from one another. Okay. So for this one here, you can just go with like a real value. That's absolutely fine. But just remember, like date and time do have their own ones. You also have varchar instead of string. I have seen sometimes when they're a little bit lenient with that though, when they do let you put string, but I think it's just, again, it's a good habit to get into. If there's like text there, remember varchar, variable character. So that means that you can have as many characters you want and it can be variable, like a surname is going to be a variable amount. And a char is where it's going to be a fixed amount in there. So like a telephone number will not change from the size that it is. So that would be maybe more likely to be a char. So anyway, yeah, that's just one of those. Just they're not the same as programming ones. They're similar but not the same. Just got that there. Get rid of that. Okay. Give the name of the field that could be used to store a Boolean data type. So let's go back onto there. Adverts. Okay, so I just thought I'd quickly change this because it's easier if this is on here. We need to make a query which goes across multiple tables, which some people find quite hard. So I want you to see the table so that you can see what we're doing. So let's go with this. So it says, first of all, remember it's always going to be select from, where, and potentially order by, but I don't think in this case we need to do anything to do with order by. And in the middle, we're going to do the little join thing so that we can join the tables between them. Okay, so first thing, and it's always like, look, if you forget the join thing, there's no sweat. It's a 5-mark question, this. If you can get 2 out of 3, 2 out of 5, 3 out of 5, it's absolutely fine. Like, that's still loads of marks in this, so, you know. Indicates, so it just wants to return the username and first name, so let's do select. They will, I'm pretty sure that they will be really strict if you get the, if you mess up case. So not necessarily with the select part, I'd just do it anyway because it's a good habit. But can you see here how it's like first name is like this, which is a little bit one of those. So it wants username and first name, and can you see how that is? So just be really careful, and separated with a comma. I see people put and all the time and drop marks. No good, no good. So yes, do not do that. And then what we're going to do is from, which is obviously the table name. So again, I'm going to listen to my own advice and put from. And so this is where what we're going to do is we're going to go for, so this one here, we want to go for, we want to display the information that where the adverts are true, okay? And we want to display the information from here. So the reason that I'm going to put membership and I don't put here is because I'm displaying the information from here, okay? So I'm going to put from, and then I'll put membership. So again, be really careful with spelling like this, okay? That's all that there. So then that's like that. So you'd be getting, I think that would be 2 marks there. If you did all that, that's 2 marks. So loads of marks there up for grabs, which is relatively straightforward to get. And this is where it's a little bit more of a complicated part, where what we're going to do is we're actually going to use the join keyword. So we're going to use join. And this is where we have to create a relationship between the 2 tables, where we're going to join package, which is, this is the one where we're going to get the information from. So remember, case, package, on, and then we're going to put membership dot package type, which is, that's the package type. Just be really careful with spelling. So you can use the dot notation on this one as well. I've also seen people just use the dot notation where they would put like membership dot username and membership dot first name. That's absolutely fine as well. People would say it's a little bit unnecessary because username and first name are not in the other table. It's used to distinguish which one you're talking about. But yeah, you can do that as well because it's a good habit to get into, and it's going to be equal to package, which is the table name of the other one, package, and then we're going to put package type. Okay, so that's good. And then final thing of what we're going to do is we just need to put the where part. So we're going to put where. I can't even remember what the thing was. It was adverts equals, and then it's going to be true. Little bit, because obviously I can see why that they've asked which one could be a Boolean data type, because normally the Boolean ones are have a capital letters, so I can see that's a little bit sneaky, that one there. But yeah, just be really careful because obviously it says it there, so we don't want to drop any marks for any of those ones there. So that's how you do that one. Okay, if you're enjoying this, people, and you're getting lots out of it, I will put a little link to our community in the description, which you can check out. But if you don't want to do that and you still want to keep getting free stuff, please check the rest of the channel out. Like it all helps because these videos do take a really, really long time to make. But anyway, let's keep cracking on. So with the method up here, what we're going to do is, for capturing a new customer's information, is we're going to put a web form, or just a form, will be fine. And it says suitability here. Now, this one has validation checks that will make sure that the data entered is reasonable. So those are things like if you needed to enter a password that was at least 8 letters long, potentially what you'd do is you'd have a length check in there, which would stop it from entering anything less than that. So there's lots of different validation checks that you can perform on a form. Okay, so sometimes the company may need to move or back up the data they hold about customers. Identify 2 methods for exchanging data with computer systems in there. So this is a very strange question. I think when I was marking this, I don't think I saw anyone, or well, not anyone, but not many people were able to get this right. And it's not very obvious what it's talking about here. It's essentially looking at files, okay, that you could transport the data with, which if it just said name 2 files that you could potentially put the information on there. So the 2 files you've got CSV, then you've got JSON. Okay, so there's lots of different ones. XML is another one. But not an easy question, that one. I mean, now you know the answer, it sounds easy, but it's not that obvious on that one. The database supports ACID transaction. ACID stands for atomicity, consistency, isolation, and durability. Describe what is meant in terms of durability. Okay, so there's a lot of this stuff where it's just about knowing the definition and, again, knowing the buzzwords. So data is committed and is not lost even if there is a power failure. So essentially what it means is just if something's durable, it means it's not affected even if the worst case scenario happens, that potentially, the power could go out and then we just lose all of the data. And this is all to do with, like, if you're booking something online or whatever it might be, holiday tickets to a show, whatever it is, it's you don't want to, essentially, you just don't want to lose it just because, you click off it or whatever it is. It's going to reserve it for a bit of time, okay? Give one way that durability can be achieved in there. So essentially what we can do is we could store these on secondary storage. Can store data. Okay, so again, buzzword is going to be secondary storage there. Explain how record locking can ensure that is used to ensure that ACID principle of isolation is achieved when carrying out multiple transactions. So with all to do with the idea of isolation, it's this idea that essentially every transaction can be carried out sequentially, okay? And record locking means that if you go onto a database and let's say that you want a particular ticket, and then somebody then after that gets access to the same ticket, that they can't finish the transaction before you and essentially steal your ticket, is that we can use record locking to help us out there. So what I'd be doing is I'd be stating, in this case, like isolation is where transactions are carried out in sequential order. We can use record locking, which will only allow one person to modify or change a record whilst a transaction is going on. And then I just explain that whilst a transaction is being carried out, the data cannot be modified elsewhere. Just an end there. There we go. Okay. The kind of main disadvantage of this though is it can cause delays. So this is all to do with when people are like waiting to go to festivals or something like that, and they're waiting for the records to they're waiting for all of those. It can cause delays, so it can cause this thing called deadlock. Can happen, which essentially is just where delays happen. The Copyright Design and Patent Act applies to all videos that are streamed. Explain how this applies to videos. So the Copyright Design and Patents Act is all essentially protecting people's intellectual property. Okay, so with intellectual property, it's all to do with this idea that you, as the owner, you own the you own the video that you made, or any device or software or any art that you that you may have created, and somebody just can't come in and steal it. So it just essentially means is it's automatically assigned to you when you create a video, and that means people will be prosecuted if they were to distribute your video without permission. Okay. Okay, so all videos are streamed, are compressed. Customers have the option to choose from watching the videos with lossy or lossless compression. Explain how this choice will impact the customer. So it's a 5-mark question here. We need to be thinking about describing both of them and thinking about how essentially this is going to be working. So what I'll be doing is I'll just give a little description of lossy compression to start with. So lossy compression is where the file is permanently changed to reduce the file. So that's a generic point, and then what I would do is I would apply this to the scenario. So for a video, lossy compression would be to reduce the color depth or audio bit depth, because video you've got audio, so audio bit depth. This would change the file, and it is often done so it isn't easy to tell, but you get a much larger data reduction than lossless. So in most cases, the reason that lossy is used to kind of by the big tech companies like Amazon Prime, Netflix, what they're going to be doing is they're going to be using lossy compression, so that you essentially don't have to stream, because you have to wait to stream things. Lossy compression does this. Lossless is where the file is reduced, but not as much as lossy, often. Not always the case, but often. This will create dictionary of repeated data, such as numbers of pixels that are the same. Then the video file can be fully recreated on the other side. If this is important, it can reduce the file partially, but not as much as lossy. So the situation is if it's really important that the file has a massive data reduction, generally you're going to be using lossy. But lossless allows you to recreate the original, can be fully recreated. Yeah, I did get that in there. So if you need the original, you use lossless. If you don't need the original, but you just want a big data reduction and speed and all that kind of stuff is really important, then you'd use lossy. Okay, so we're going on to a little bit of OOP here. So a program is written using object-oriented programming paradigm and uses a class called video to organize the videos that are streamed to customers. The class video has these attributes: name, number of views, star rating. So we've got those attributes there. The constructor method will set the name attribute to the name that is passed in as a parameter. The constructor will initially set the values of the views, so it's telling us here 0 to that. Program code, write this in program code or pseudocode, so I'm probably going to do this in Python. Initialize the required attributes as private. You should include both attribute definitions and the constructor method in your answer. Okay, so attribute definitions and constructor. Okay, do I have to make the class? I'm gonna do it anyway. Okay, so in the little community, in the A-level community, we always talk about this, how OOP questions are literally exactly the same every single time, apart from obviously they change the scenario. They always ask you about the constructor, they always ask you about getters and setters, they always ask you about inheritance, and they follow a pattern every single time. So let's have a look at how we do it. Class, video, colon. Then what we're going to do is we're going to do our constructor method, which we're going to put def underscore init underscore, not init like British slang, but initialize self comma, and then we're going to put name, and that's the only one that it wants us to do on creation. So what you do is you put the attribute in here that you want to on instantiation. Instantiate is just a fancy word for create. We put that in there like that, and then we're going to put colon, and then what we're going to do is then we're going to go like this. So self.name equals name. Just make sure I've spelled everything correctly. Look, check, always checking, keeping at the back of your mind. Have I put a capital letter there? So self dot. What was the other thing in there as well that I wanted? So they want number of views, so I'll put num views. Might put it like that. Have they given us They haven't really given us a name for that one, so I'm just going to put num views equals, and they just want that as 0, and then star rating. So self, not star rating, equals to 3. Okay, so there's those things. So that's the constructor there, people. The indentation there, I've tried to do it as best I can, but those self should all be in line generally. Obviously they're not going to be too over the top on those ones, but that's how you do the constructor. Attribute definitions and the constructor method that you need. Okay, that's cool. Let me just have a look. The only thing I was just thinking of is if they were talking about private there. See, I actually went back and saved the day there. So here, to set them as private, you have to put 2 underscores. I just thought that was a little thing just before I went on to the next one. Set them as private, you do this, like that. 2 underscores there. 2 underscores. 2 underscores. Whew. You can even, to really hammer that home as well, you could put a little comment next to it being hashtag private, just so that you're like really spelling it out to the examiner, like, look, I've read the question, I understand. Attributes are generally private, methods are normally public. So let's have a look. A public method, well, that's funny, went on to that one. Update views will update the number of views after a video has been viewed. The method is defined inside the video class, that's fine. Write a program or pseudocode for update views to increase the number of views by 1. Easy stuff. So what we're going to do is going to do def, update views, just make sure you spell it exactly the same. As you can see, self, and we have to use the same name that we've put here, so num views. So we're going to put, I'm just going to put it in here like this. No comma there, and then what we're going to do is then we're going to go for self dot, make sure you call it exactly the same, so view, what did I call it again, what was it, view, num views, so it has to be that attribute that you put before, so num views equals, or we can do it like this, plus equals 1, which just means self dot num views equals self dot num views plus 1. Yeah, so that's all that done. So it's not quite a setter, but it is it's just like updating a value in it. Okay, so that is all of that, so that's all good. So now convert these into so it says convert the hexadecimal number B7E into a binary number. So the way that I would do this, so I'd go B7E. The amount of people that I see get this wrong, okay, just take a second at any hexadecimal question. What I want you to do is I want you to go A is 10, and then when you get to the letter, just do B is equal to 11, because I see people guess and they're like B's 12. So then we've also got E as well, so we need to do that 12. Or they take a gamble, E is 13. E is not 13, E is 14. So just make sure that you write it down, just to slow you down a little bit, because these questions on here, they're going to be really important. So then what I'm going to do is I'm going to put 8, 4, 2, 1. 8, 4, 2, 1 underneath of each of these. 4, 2, 1. And 8, 4, 2, 1. And what I'm going to do, so for 11 there, I'm going to put 11 above it. That there, 14. And then what I'm going to do there is then I'm going to go 1, 0, 1, 1. And then we're going to do 0, 1, 1, 1 for 7. That's obviously 11. And then you just treat them separately. So then 1, 1, 1, 0, like that. Okay. So that there. So this is your number here. That's going to be your there. So convert this into a denary number. Okay. We don't have calculators in OCR. So cross these out, or maybe get rid of them. And then it's just going to be a simple case of 16, 32. 64. Well, oh, that would have been bad. I just assumed that wouldn't make any sense. Well, clearly, I've been doing this for too long. But it's yeah. So I just assumed that that would be to do with that, but that wouldn't make any sense, would it? Like if just giving you the answer to the next one. My bad. But anyway, if it did ask you to do that, you would just cross those out and do that. So write the number out. 1, 1, 0. Like, be really careful that you actually write the correct number out. 1, 0, 1, 0, 1. So just double check 1, 0, 1, 0, 1, 0, 0, 1, 1, 1, 2, 4, 8, 16. I'm just doing it above the 1s, 32, 64, 128, and then 256. Okay, so just keep doubling. And then, as I said, I probably would not take any chances. Bit of column addition in there, people. Why not? So I'm going to go with that. So 8 plus 6, 4, carry the 1, 7, 3. So 374. Okay. Binary subtraction. Both are 8-bit are represented using 2's complement. Complete the following binary subtraction. I'm actually going to do this on a new page because I want a bit more space. So let's get that. With this one here, binary subtraction, we're going to use the rule that if I did 7 plus minus 3, that actually gives me the same answer as 7 minus 3. Okay, so what we're going to do is we're going to 2's complement the bottom number, and then I'm going to add it on, and it's going to give me the same answer. Okay, so we use that little rule there. So to 2's complement, this is a little one for the bottom one. So step 1, 2's complement the bottom number. So I go from right to left, and I go and find everything at it and before it stays the same. Everything after it is flipped. So I go 1, 0, 0. So everything at it and before it stays the same. Everything after it's flipped. 1, 0, 0, 1, 1. And then I'm going to write it underneath everything. 0, 1, 1, 0, 1, 1, 0, 1. So make sure you get the top number correct. And then underneath it, write your new number. 0, 0. 1, 1, 0, 0. Underline all that. 1, 0. 1 plus 1 is 0. Carry the 1. 1 plus 1 plus 1 is 1. Carry the 1. 1. 1 plus 1 is 0. Carry the 1. 1 plus 1 is 0. Carry the 1. And we get a little overflow error there. So we're just going to cross that out there. So this is going to be our number here, because that's how the number actually gets smaller, is it uses the overflow error to kind of create that situation in there. So that will give us the right answer in there. Lovely. Okay, so we've got the floating point number there is used to store 4 bits for a mantis and 4 bits for an exponent, both using 2's complement. Okay, so, okay. Tried to be a little bit sneaky on this one here, as I can see, because what they're doing is they're trying to... what they're trying to do is they are both negative. Now, I know that because both of them have got 1s at the front. And if it's got 0, it's a positive number. 1 is a negative number. So they're both negative, which is the most difficult one to do. But I'll show you how to do it. So split it up. So you've got the mantissa and exponent. Okay. This is the binary version of, like, by the way, standard form, which is like 3.4. It's like a way of representing this. Yeah. So that's what we're doing here, people. As if I've got videos on this, so do check them out where I literally go through everything in it, and also, you know, community group. Sorry, I will shut up about that now. But yeah, anyway, so we've got 1, 1, 1, 0. Okay, first thing I've got to do is 2's complement both of these. So 1, 0. I haven't done that right. Go to the first one, everything at it before it stays the same, everything after is flipped. So 0, 0. Okay, this, if we do that, 1, 2, 4, so that actually gives us -2, okay, because obviously we've 2's complemented it, so the answer has to be negative, all right? And then I'm going to 2's complement this, everything at it and before it stays the same, everything after it's flipped, 1, 0, okay, right, and the decimal point is always between the first two numbers there. Now, what's going to happen here is we add the number, because it's a negative number. If that was a negative number, this would become a really, really small decimal number. It's the same here. So I need to put 2 zeros at the front, which is the 2. I put 2 because there's 2 there. If there was 4, I put 4 zeros. And then I'm going to move it 2 places to the left. 1, 2. 0.0011, 1. I personally prefer working with fractions, but you can use decimals, so that would be 0.5, 0.25, 0.125, 0.0625. That weirds me out, so what I would do is I'd go for an eighth and then a 16th. Add those two together, so that's 2/16, so then that's going to be 2, so that would be 3/16. And what does everybody forget to do? Put the minus at the end, so that's going to be 3/16, minus 3/16 there. Or if you did that, it'd be 0 minus whatever that is. I'm not going to work that out in my head. But yeah, I'd recommend using fractions just because fractions are a bit easier. If you do an AQA, you get a calculator in the exam as well, which is quite nice, but we don't in OCR. So yeah. Table 3 shows floating point that are 6 bits for the mantis and 3 bits for the exponent. Both are in 2's complement. State whether it's normalised or not. A number is normalised if it is 0, 1 for positive or 1, 0 for negative at the front. Okay, so let's have a little look. So that one is normalised. That one isn't normalised because it's 1, 1 at the front, as you can see there. So you're just looking at the mantis apart here. That is normalised because it's 0, 1. And that is normalised. So it's looking all good. So we've got normalised, not normalised, normalised, and normalised there. This is going to be the last one I'm going to have a little look at today because I've been doing this for quite a while today. But, you know, I hope you found it useful and everything, people. And as I said, please do help the old channel out and everything if you can do. But yeah, and, you know, comment on any other exam papers that you want to go through. As I said, I'm going to put a part 2 out next week, and then I'll like join it together so you've got the whole paper, but I'll be working through various different ones. But if you're just like, this one I really want to go through, or this is another exam board, stop leaving us out in Cambridge International, just tell me and I'll do it. Okay, so 9 marks, AI, discuss the extent to which computer systems will inherit biases and discrimination of the programmers as the AI increases. We need to talk about the meaning of AI, examples of when AI are affected by bias, the measures that can be taken to prevent people from being affected by AI's bias. Okay, so what we're going to do is we need to go with our policy of say what AI is and then talk about the application of that. So how I'd start this off is let's just talk about AI. Okay, so AI is where large language models analyze large amount of data and make predictions on what will be the best answer to answer in a given scenario. So we don't have to go quite into as much detail as we did on the other one because this is 9 marks, but you know it's still the same format. Describe it, how it can be affected by bias, what we can do to mitigate some of those things. So yeah, anyway, it's going to use machine learning in which it uses a large amount of GPUs to learn patterns in solving a variety of different problems. This used to be only tasks that humans could do, but now AI can perform tasks such as solving maths problems, programming problems, advice on a variety of different topics. Okay, so examples of where they might be biased in this. So scanning the whole internet will generally allow for limited bias, as there will be conflicting points on every topic, but this has been shown to have some bias. For example, in with Google's AI. So I'd maybe give like an example. Google's AI was given certain parameters and only looked into some areas and not all. This then, in its answer, would give left-leaning positions as opposed to a well-rounded perspective. So I'm just to maybe talk about an actual example that you know about in the news. Like that's one. So Google, what they did is they had it was outputting things that were incredibly kind of like really liberal, that's not it. I'm not saying that's an issue. I'm just saying that there's something that clearly there's a bias that the programmers have gone for. Now, one of the things that we could talk about as a potential solution is that we're trying to avoid people living in what are called echo chambers, where they just listen to things that they want to hear. So it would be better if artificial intelligence maybe was a little bit more down the middle. Essentially with all of this though, it's with all of the different types of artificial intelligence, as it develops, there's going to be different ways that artificial intelligence works. So it potentially might not be scanning the whole internet, so there may be a slight bias in there as well. So we could also give an example for DeepSeek as well. Well-rounded position. DeepSeek, newer model, which doesn't scan the whole internet and tries to be more efficient with hardware use. This has the advantage of needing much less GPUs, but there has been some reports where it is quite biased in some areas. Okay, so again, talking about an example that's been reported in the news. We're not making a judgment based on it. Simply all we're saying is this has been reported. So there have been some situations where this has happened. And what we need to talk about is how we can essentially put this right. So testing is going to be really important, and having lots of different sources that the AI will use to gather information to not be biased. It also needs to have programmers from all different viewpoints in creation, so that there is no bias coded into the actual creation of the AI. Okay. Again, I'd be spending just under 9 minutes on this, generally trying to think that you're doing things a little bit more efficiently than I mean, 9 minutes would probably be fine. So a minute a mark, if you think about it like that. If you're spending way longer on this, move on. You do not want to miss out on everything. So that's a really big thing. We're going to stop there for today. And what we'll do is I'll release the second part of this next week, but I'll put it all together for you so that you've got a complete one that you can just watch through. But anyway, hope that was useful. Take care. Right, part 2. So what we've got here is we're going on to functional programming, which is where we have to look at this program and then essentially work out what is it that it's going to output if we put these values in as parameters. Now, with functional programming, it's going to take, in this case, it's going to take 2 parameters, which x is going to be 10. So x is going to be 10 for the first one. Y is going to be 20. And essentially what I'd be doing here is just tracking it through using a trace table. Total, you may want to put a little bit for that as well. So total equals x plus y, which is going to be 30. So we've got 30 stored in there. Y, x, while x is greater than or equal to 10, which is true because it's equal to 10, then x equals x minus 10. So that's going to be 0. Now, the thing with this is it does have to do one loop of it before it stops. So even though the statement is now not true, it gets to the end of it and then it will stop. Okay, and then what's going to happen is then it's going to do y equals y minus 10, which is going to be 10. And then the next thing is then it's going to do total equals total 30 plus x, which is 0, plus 10, which is going to be 40. And then it's going to finish the while loop and then it's going to return that. And in this case, we're going to be outputting it. So that's going to be 40. Okay. Now, if we go back through and just what we'll do is we'll just go through and make sure. This is probably what I'd do is I just have almost like a little trace table for this, because it's just going to help with tracking what's going on with the different variables at all times. So I'll just get rid of those, or you can cross them out on yours. And then what we're going to do is, so we've got x is going to be 0. So 0. Y is going to be 70. And then we've got total equals total. So total equals x plus, so that's just going to be 70. And then it's not going to activate the while loop because while x is greater than or equal to 10, that doesn't get activated. So it's just going to skip all of that and then return that, which is going to be 70. Nice easy one there. Take that out. And then we're on the third one now, which is going to be, so in this case we've got 45 and 55. So we're going to go with 40, 45, 55. And essentially with this, so we're going to add those two together. So that's going to equals 100. Now the while loop is going to be activated. So it's going to do x equals x minus 10. So that's going to be 35. Y equals y minus 10. So that's going to be 45. And then what we've got to do here is then we're going to add those two together and then add it onto total. So 35 plus 45 is going to be 80. Add that onto 100, so that's going to be 180. We go back up to the top because the while loop's still true, so then that's going to be 25. That's going to be 35. That's now going to equals 60. So then we do 180 plus 60, so that's going to be 240. This is still true. So we're going to do, in this case, we're going to do 15, 25. 15 plus 25 is going to give us 40. Add that onto there, so then that's going to give us 280. And then we've got 5 and 15. Remember, it goes all the way through the while loop before it checks the condition again. So 15 and 5, so then that's going to be 20. Add that onto there, so that the final answer is actually going to be 300 on there. Okay, so that's just with the functional programming there, just like a normal functional program. If you understand that, then that's going to be relatively straightforward. But let's just do a bit of practicing with functional programming and def statements, functions, procedures, if that was a little bit confusing for you. Okay, so now we've got on to B. Before the code can be executed, a translator must be used. State the purpose of a translator. A translator, 1 mark, job is to translate high level, and technically we could also get slash low level languages, or maybe we could say assembly language actually, so assembly language into machine code, because an assembler technically is going to just convert assembly language into machine code. Explain two differences between a compiler and interpreter. Okay, so a compiler. So they're looking at here, exam technique is 4 marks. So we've got to make a difference, but then expand on that. Okay, so it's not just stating a difference, because you'll only get 1 mark for that. So remember, state the difference, but then also sort of go into a little bit more detail about why that is the case. So it could be that, well, it's probably actually going to be more to do with, like, you could say the compiler difference and then the interpreter difference. So we could say compiler translates code all at once. Interpreter will translate line by line. Okay, so that's making those 2 points there so that you get 2 marks for it. The difference here is, another one is that so the compiler will give you an executable file at the end of translation. Interpreter will not give you executable, and you can still see source code. So one of the things with compilers is that you can't see the source code after you've compiled it, which is why, you know, computer games companies and things like that will always give you the executable file, which is what you buy when you've got the software in there. Okay, so what we've got to do now is we've got to do the different stages of compilation, which is lexical analysis, syntax analysis, and code generation. And there's different features that happen in each of these, and we've just got to put a tick in the box where it happens. So comments and white spaces, lexical analysis. Keywords are replaced with tokens, lexical analysis. Object codes is code generation, that's the last stage. Symbol table is created for variables, lexical analysis. Little clue on this one because it says syntax analysis. Now, the purpose of code optimization, which is a part of compilation, is where we're essentially trying to make our code more efficient. So I think this is one of the ones where I think people would say they would get the efficiency part, but the thing that they maybe wouldn't get is the second mark in this one, which is actually quite hard to get. So always think about, if it's 2 marks, make 2 solid points. So to make the code work more efficiently, and to make the program, this is the second mark, use less resources like memory. For the next stage of functional programming is we've got a function which is essentially going to count the number of capital letters in some text, and how it's going to do that is it gets the ASCII numbers, so between 65 and 90, which are the capital letters in ASCII, and what it's going to do is it's going to check for those, add 1 to a count, and then it's going to return how many of those values were there. So essentially what we're going to do is, in this part here for the if statement, this is where we need to check if the number is between 65 and if it's between 90. So it's going to be, and remember to put ASCII there, and then we're going to put less than, equal to 90. Okay, so that checks between the range to check if it's an uppercase letter. We're then going to do cap count, make sure that you get the capital letters in there, cap count +1, and then finally at the end you're just going to return that value there, so that's going to be cap count there. So the one similarity for this one here is that they are both, this is just a 1 marker, both used to represent different characters on, both used to represent different characters, and then it says 2 differences with them. So the similarities is they're both used to represent characters, but here I'll be talking about the difference in the number of characters you can represent is the first thing. So because it's only 2 marks, you just have to make 1 point on this one. So let's say ASCII has much fewer characters, and I'd really hammer that home saying only 128. Or if you wanted to say 256, it's up to you if you go 7-bit or extended ASCII. The other one as well, the other difference is Unicode can represent non-European languages, which is why Unicode was brought into, because European languages generally have a similar alphabet, and 256 characters was about enough to get around European languages. If you think about Russian, Arabic, Chinese, Japanese, all of these different languages, they have completely different alphabets, so we needed to bring in something else to be able to represent those characters in there as well. So what we've got here is we've got another, and I think it's the last one on there, which is a 9 marker, which is all to do with essentially talking about the different stages of the software development life cycle, and it's a 9 marker. So we can see that it's really important that we get this strategy of how going through and writing in, describing what it's talking about, and then applying it to the scenario. So the scenario is that a client is going to try and create a complex computer system, and they want to compare the spiral model and the waterfall model. So essentially what it says is how both methodologies could be used to develop a complex computer system. So obviously functional, the benefits of each methodology for this task, the drawbacks for each methodology for this task. So we're just going to go through each of those. So again, the first paragraph is going to be so important just to outline that you actually understand what each of those things are. So I'm just going to make some points about waterfall. So the waterfall model is where you have the different stages, and if you can remember all of them, that's obviously going to be great. So think about your NEA, analysis, design, programming, evaluation, and testing. And what the model does is it starts at the top of the waterfall analysis, and in a linear fashion goes through each of the different stages. So I'm just going to outline that I know what the waterfall model is, and then what I'm going to do is I'm going to talk about the spiral model. The spiral model is has the same stages, but makes use of prototypes throughout development. So what might happen is in development is you might go through 3 or more iterations of each stage of the software development life cycle to keep refining the project through getting feedback after you have finished a prototype. Okay, so I've just outlined what each of them are. Now, in a complex model, now we need to start applying this and evaluating it and saying about why something's going to be good, why something's going to be bad. So one of the big benefits of a waterfall model is the waterfall model is really good if the program that we are making is easily understood and has been completed lots of times. For example, a complex computer program could mean building a website. If this company that was employing this model, I don't think employing is the right word, that was using this model, had completed similar projects before, it is going to be the most cost effective. And then what I would do is then I would link this to the spiral model, but I'd maybe make a negative point about it. Spiral model is for businesses where it is going to cost a significant amount of money, as you have to make multiple prototypes. And also the development time is going to be a lot longer than if you used waterfall. It's getting a little bit weird there. I'll move it over here. Okay, use waterfall. Okay, so it's going to be a lot like that. If I'm honest, I'd probably go for another advantage and disadvantage. So I'd go for an advantage of a spiral. It has said that it is a complex problem, though. So the benefit, or the main benefit of spiral, is that it takes longer, which isn't a benefit, but takes longer, but it gets it closer to the user's requirements through prototypes and asking the user how to improve each prototype. The waterfall model, you cannot go back up the waterfall. So this may lead to making a program that isn't what the user wants. So if it's a really complex program, so again, it's just essentially, there's no right or wrong answers in these ones. I think generally they're trying to say like that what you want to do is you want to go for the spiral model, and talk about how the spiral model could be used because it's a complex problem, and just talking about how development time is going to be longer, it's going to cost a lot more money. But one of the big benefits of this is because you're making prototypes throughout and you are constantly talking to the user and saying, this is, how do we, what's going to be the things that we can do to improve this prototype? And because you do the iterations going through each stage over and over again, you trade off the development time and cost so that you actually get it closer. And that's if it's a complex program like that. So I think that's obviously what the question is asking us to do there. But just make sure that you're going with that strategy of define what the waterfall model is, define what the spiral model is, and then just make some good points about it, because the waterfall model does have some benefits. It's a very simple model to follow. It's if it's a website that they've made before, it's probably just going to be that they can just use a template that they've done before and change it to fit the user's requirements. So again, that would be something that I'd be talking about in there. But trying to make at least 2 advantages and 2 disadvantages. If you've got 9 minutes, I would say give yourself 9 minutes on this, 10 minutes on this. If you're going way over that, stop, finish the rest of the paper, come back to it so that then you don't go over in the actual time. Okay, right, unit 6. So question 6, I should say. So let's have a little look. So we've got multitasking operating system. She has access to a printer. Broadband internet connection through wireless connection. The operating system uses scheduling algorithms such as first come, first serve, and round robin. Okay, explain why a computer's operating system uses a first come, first serve when sending documents to a printer. So this is going to be for the printer queue, and everything has equal priority when going to printer. So essentially it's this idea that when we send something to the printer, things generally don't have priority over others to be printed first, unless it was some kind of strange situation. It's just whatever gets there first, we need to print it off. So what we would do is we'd implement essentially what's called a FIFO data structure, first in, first out. If it's first there, we're going to take it out of the queue, print it, and then on to the next one. Explain why the computer's operating system uses a round robin for allocating processor time. Again, quite a tricky one, this one, because essentially it's 3 marks. I think people will maybe be able to get a mark on this, but yeah, no, it's quite hard with the round robin. So explaining in this particular situation, so round robin is the concept of where we give a time slice to each job, and if we finish it in that time, great, we move on to the next task. But if we don't, then what happens is then we go on to the next one, onto the next thing, so to make sure that everything is fair. Now, in terms of processor time, this is a good way of making sure that fairness is ensured. So we kind of need to get this in there and explain like why we think this is. So this allows for, I think the buzzword they're going to be looking for. So this allows for multitasking. Multitasking, which if you I always talk about that, how important it is for the buzzwords in there. So like you need to make sure that you've got those ones in there. Multitasking, if that's not there, they won't give you a mark for that bullet point. There's multiple ones that you can use, but that's going to be really important in there. So it's going to be, I would then go into the point. It gives a time slice to each process, and will work on for that period of time, and then if it finishes, the task moves on to the next task. If not, if the time runs out, we'll move on to the next task, and then puts the task it didn't finish to the back of the queue. Okay, and I think it's just to really talk about how the processor is going to use this to essentially efficiently go through all of these, and talk about how it's really important that it does these things as efficiently as possible. Okay, and then it just says describe another scheduling algorithm in there. So we've got the one that I would probably go for. Well, there's multiple ones you could do. Which one did it said in there? So it said first come first serve, round robin. So we've got shortest job first, and then we've got short, which is probably going to be the easiest one. So shortest job first. The job with the shortest amount of time is going to be is processed first, which is just that nice easy one for there. You get a point for that one, point for that one. Okay. Now we're going to have a quick look at these ones, which is talking about the TCP IP stack. It says explain what happens at the application layer of the TCP IP stack when using this program. Okay, so and we use an encrypted messaging program to communicate with our friends. The computer uses the TCP IP stack, and it's a 5-mark question. So at the application when using this program. Okay, so this is where we need to be talking about. So it's talking about messaging, and we need to obviously relate it to the scenario there, but we need to be thinking about the stack, protocols that are going to be using. So this is what I'm thinking about in my head. Protocols that are going to be used. If I'm going to be passing the information down to the transport layer, because we're going from application to transport layer, and how that's going to operate. So yeah, let's have a think about that. So the application layer is where the messaging program is going to be used to send the messages. If this is an email, we'll be using SMTP to send the emails from there. So I'll be talk about that. I mean, it's not too clear about whether it's emails and what's going to be going on there. But the other things that I will be doing that will be helping me to get marks potentially in there is talking about how the application layer passes down the data to the transport layer. And thinking about the stack in the order in which these things are in there. So the application layer passes down the data that is going to be sent to the transport layer. Okay. So to get the final marks on this, what I'd be saying is, because it says this is just what happens in the application layer when using this program. So it's not actually like sending all the time. What it's going to be is it's going to be also receiving. So we can also get the marks as well. This is the thing that I always tell my students. So what I'd be thinking about in this is that in the TCP/IP protocol stack, essentially what you've got is you've got the application layer. I'll just put app. Then you've got the transport layer. I'm going to type this because I'm clearly not doing very well on that. Then you've got the internet layer, internet layer or network layer, whatever you call it, and then link layer. I know they're different. Sometimes people call it different things. So you've got the different layers. So you've got the application transport. And this is essentially here, what I'm going to be talking about is I'm going to be thinking about which layer is the layer it's talking about touching. So it's still touching the transport layer. So it passes things down to the transport layer, but also when it's receiving data, it takes data from it. The other thing as well, which I know sounds a little bit obvious, you can also actually pick up a couple of marks here for just saying this is the layer where it encrypts it, and then I'll maybe put in there HTTPS. So if they're doing anything to do with that, that's what's going to be doing this. Also, because it receives it, it decrypts it. If it's received a encrypted message from someone, and also decrypts message. The other thing as well to get the final mark on there is I talk about how it receives the data from the transport layer. So that's another thing. So this one I always see students really struggle on, and it's just think about the layers. So the first thing I'm thinking about is protocols. What protocols operate at which individual layer? Then also what I'm going to be doing is where am I going to be receiving the data from? So explain what happens at the link layer, sometimes referred to as network interface layer, network access layer, or simply the network layer. Of the TCP, I've actually heard the internet layer also referred to the network layer, so that's really confusing. Of the TCP IP stack when using the protocol. So when using this program, sorry. So the link layer again, so it's 2 marks here, so it's going to be receiving data from the internet layer. It's going to be also this is the one where it if it sending data, it attaches MAC addresses on, and then you can do the inverse of it. So it receives data from literally from the internet. It's going to take off the MAC addresses and then pass it up to the internet layer. So you can do it the other way around as well if there are more marks there. And then essentially, all we've got. Oh, that's actually going to be it. Okay, so that's the end of the paper, people. So I hope you found that useful. Please do give it a little comment if that was really useful for you. And I'll keep making more of these. So thank you very much, people.